scale factor involving areas and volumes. Yikes. Not really, but if you pay close attention, there's a slight change, but really the basic idea stays the same. And I want you to remember that areas, that would be a two-dimensional, right? A square, a circle, rectangle, triangle, anything like that that's flat is a two-dimensional. And even surface areas for that matter. Volume, we're thinking 3D. And focus on the number, the 2 and the 3. Okay. So let's start with one-dimensional, right? That's what we've been doing so far. If you have an original line like this, let's say that's 2 centimeters, and this is the original. Let's say you take that original and you double it. K is equal to 2, which means it's going to be twice as long. So try to make it twice as long, just eyeball it. So that means that this will be 4 centimeters long. And so this is what we call our new dimension. And if you were to take new and divide it by the original, that would be 4 centimeters divided by 2 centimeters, and you get 2. You're like, yeah, so what? I knew that already. Because I'm building something here. K is equal to 2. When you divide them, you got 2, right? What if you're dealing with 2 dimensions? A 2D. So I'm going to cut it here, okay? Just to keep that one separate from what I'm doing next. 2D. So let's say you have the original here. And I'm going to use, for demonstration purposes, I'm going to stick with a square. Or I could do rectangle. I can handle rectangles. But let's say we just have a rectangle like this. And we have 3 centimeters here and 2 centimeters there. And let's say you're taking that and you're making a replica, and just for now, we're going to say let's double it. Let's make it twice as big. Well, every dimension on the original is going to be affected by a factor of 2 in this case. So, right, like this, the width here will be twice as wide, and the length will also be twice as wide. So leave a little bit of room there, right? So the 2 centimeters turn into 4 centimeters, and the length here turns into 6 centimeters. Does that make sense, right? I'm just doubling it. I could shrink it, but I'm choosing to double it just to demonstrate a point here. And this is my new shape. But we're talking two-dimensional, right? So the area here, area of original, is going to be 2 times 3, which is 6 centimeters squared. I think you can handle that, right? The area of the new would be 4 times 6, which is 24. Does that look like double to you? If you look at the areas, where the areas doubled, doesn't look like it, does it? Let's see here. I want you to do this now. Let's take the area of the new and divide it by the area of the original and see what happens there. The new is 24 centimeters squared, and the original is 6 centimeters squared. Cancel out the units. 24 divided by 6 is 4. What happened there? Well, the 2 has affected your width and your length. So 2 times 2 is 4, right? So really what happened there is your scale factor has affected 2 dimensions, so it's 2 squared, right? So I will make a note here that the new area has been increased. I'm going to move it up a bit. New area has been increased by k squared. Okay, that's very important to, and I will do this, area and k squared. Okay, so when you're saying, hey, let's look at the circle and let's make it 3 times as big, will the area be 3 times as big? No, it will be 3 squared times as big. So 3 times 3 is 9. It would be 9 times bigger if you make it 3 times as big. So the area is 9 times bigger. And let's cut this here. This is going to be trick. I'm not an artist. So let's draw our, so let's draw a box here to the best. So what I do is I make a parallelogram here like this, right? And then I just go up to a line like this. I'm going up to this line, this corner, and then I kind of try to copy this here as well. You go up the same amount, I connect. And then I try to just go parallel lines everywhere. So let's say you have a box that is 3 centimeters by 2 centimeters. And let's make the height, it's not drawn to scale, right? But it's 3, 2, and 5. And this is our original. And we are for this illustration, we're doubling every time. So we're not doing anything other than double. You could have made it half as big. You could have made it 3 times as big. We're just choosing to make it 2 times as big. So just make a box that is bigger. So I'm going to go closer to this one and just try my best here, knowing that you have an eraser, right? Oh boy. Oh boy. There you go. So then this is 6 centimeters. This is now 4 centimeters. And this is now 10 centimeters. And this is our new. Sorry, I know some of you are like upset that your notes are now messed up, right? You just get over it, you'll be fine. 3D. This is the 3D section, okay? Please hang in there till the end. So 3D, you're thinking volume, right? So volume of the original is going to be 3 times 2 times 5. 2 times 5 is 10, times 3 is 30. volume of the new one that I made, 6 times 4 times 10. 6 times 4 is 24, times 10 is 240. Did I just want to make sure, yeah. 240 centimeters squared. And now what do you think I'm going to do? Oh, yeah. Yes, yes. Thank you for that. Very important, actually. Extremely important. Now I messed up your notes again, right? Way to go. To end the week like that, right? It's Friday and Monday. You always have to watch out. Yeah, you always have to watch out. Okay, anyways. Volume of new over volume of original. Why am I doing that? Why do I keep doing that? Behold, right? You see this? That's why I'm doing that, because that's going to continue. So 240 centimeters cubed over 30 centimeters cubed. Cancel out. What's 240 divided by 30? 8, right? And can you think, if you look at your scale factor, how many times has it been, how many dimensions has it affected? It has affected the length, the width, and the height, correct? So it will be 2 to the power of 3. So note, new volume has been increased by k cubed. And I will do this, volume k cubed. And now I'm going to go up and add to every single section. I'm going to add something. Somewhere in here where you find an empty space, you're going to say that k cubed is equal to volume of new over the volume of the original. Just write that down and then box it in. That should most definitely be on your study sheet. Because we've just explored it. We know that this is true. We know that if we divide their volumes, it's really the scale factor to the power of 3. Then go up to the second section here. K squared is equal to area of new over area of original. And make sure you box that in as well. One second. I think all I'm going to do is do one example here, and then I'll send, that'll be it. Okay, so here we go. Examples. Jasmine is making a kite using a scale diagram. I know, a scale diagram with a scale of 2 to 25, like this. The fabric on the diagram is 20 squared centimeters. A, calculate the amount of fabric needed to build the actual kite. We're going to do that first. Since we're dealing with like fabric it's covering an area, so we need to use this formula. K squared is equal to area of diagram over area of actual. We need to use that. This is the only example I'm doing, and then we're done for today, okay? So you have to use this because we're dealing with areas. And so the scale factor, you already know, it's 2 to 25, right? We can replace that like this. But don't forget to square it. If it's a decimal, you still put the decimal in and square it. And so we are given the area of the diagram, which is 20 centimeters squared. So we're going to figure out this area of the actual kite, like how much fabric in this case we need to get the kite. So when you have a fraction, square both of them, right? 2 squared is 4. 25 squared is that 625? I'm just going to check. Yep, 625. So you set it up like that. See, it is at the beginning, it is the same setup except for you have a squared because we're dealing with areas. Cross multiply and divide. That's 3,125 centimeters squared. That is the actual area. That's how much fabric you would need for the actual kite. Okay. Page 7 in the booklet. That's it. I made a video where I go through that whole worksheet. So if you're stuck, it will be right under classroom. It will say page 7. The key is scanned and posted, and the video of this worksheet is also posted. Will be, not yet.